Okay, welcome everyone. We are in week 4, the second session. So, sharing work. Let's start. Okay, so we started the chapter 2. We worked on some syntax for the SQL. We started with the select, from, where, and we mentioned that these first two, the select and from, are the mandatory syntax that you need to use when you're writing a SQL, and those by group, having, order, those with the after with from, those are optional one. But in order to just write the SQL code that could run, select and from is the only things that you need. But for sure, it's a very basic codes, basic syntax, and for the rest, you need to just read the question, read the case, and then according to that, then you can make a decision to use which one of these. Okay, so just let's do very quick review for what we have done. So far, we are just working on one simple table, simplified sales table from the data, and we went through different type of syntax. So just give me your thought about this one. Select asterisks from, for example, simplified sales table. So what does it mean by these two lines? Select asterisks from simplified sales table. So what we are going to see, what does it mean by these two lines? Yes, from the simplified sales. And what is this asterisk means? Show up the columns. Okay, so it shows all the attributes, all the features. So when we are putting the asterisks, technically you're gonna see all the available columns in the table. Okay, so as in a table, we had again that example of the book and the author. For each entity, we had the features, we had the attributes. Mentioned okay, for the book, for example, the first row is the first name, first column, first name, last name, book's name, whatever, and also for the authors, again, the name of the authors, the genre that they would write the book, I don't know, their age, whatever attributes that could describe them. So technically, we put each in one table, and then with the SQL, we could request some question. We could do some query from the database that we have. So we went a little further, and then we talked about the where. So by where, which means we are trying to filter the final output. We are trying to work with different type of condition. For example, we had here that select all the columns from the simplified cell table where the category is sneakers and the color is black. So in the output, we would see all the columns from the simplified sales table, and the category was sneaker and black. So you can see we just see those black sneakers. That's it in the output. So, and then we a little went further. The order of the clauses, as we mentioned, was important. Select from, where, group by, having, order by. Chapter 2, we are almost just worked for the select from, where. In chapter 6, we will start working on the group by, having, and also the rest. So order also we use it in chapter 2. So then we talk about the or written the or the way the order that we write, and also the order that it's execute. So we start with the select from, where, but syntax in SQL, first it goes to from, then it goes to the where, what is the condition, and for the output, it looks to the select as a last syntax, and then give us the output. And then we talked if we having some duplicate value, we can just use simple distinct keyword. So just by using distinct before the, for example, manufacturer name here, we can remove those duplicated values. Okay. So we were, and then we talked also about the sorting or based on the descending and ascending. So for example, include this one, we had the category, color, and manufacturer name as a uh, output, as a column from the simplified sales table where category is sneaker, order by color first, then manufacturer name by descending order. And we mentioned that default is ascending. If you want to put the descending, you have to put descending. And also, if you want to put the color as a descending order, you have to also put descending here. So that descending is just for manufacturer name. This is what we have discussed so far. Any question? I am so happy that I see some of you already started the assignment 2.2 and 2.3, even though we haven't started 2.3, so that's great. Now let's talk about the and or not as a logical operator. So this is not the SQL, this is just the simple math that we have. So when we are talking about the and condition, or condition, and not condition, technically the output is gonna be look like this. When we have the two condition, let's say A, B, sneaker, red. Okay, so red is sneaker. Okay, the first condition sneaker, the second condition should be the red. Just consider it as a condition. By and, when you're talking about the and, when both conditions are false, false and false, the result is gonna be false. When there is a false and true, again, the result is gonna be true. We will see in the SQL how it works. True, false is false, true, true is true. So technically, if the combination of two conditions we expect it to be true, both of them should be true. But for or is different. Just one is enough to be true. The result is going to be true. Except the first one, false and false, is going to be false. And for the not, if the expression is false, the not version is going to be true. So just a reverse version of that one. So how this one works in SQL? Let's so make sure, same as previous session, start coding with me at the same time. So you can just easily open your advanced query editor, choose MySQL, and then Redcat 1. Okay? So let's start with this one. So please read these 3 lines for me and tell me what's gonna be in the output. Okay, so simplify CSV, and the output, we are gonna see all the columns for it, all the attributes for it, and we are just gonna see the sneakers that's made by Puma. Okay, so we can see here there is an and between these two. Okay, so right now the first condition, we want to have just the sneakers, and the manufacturer name we want to have Puma. Okay, if we want to just see the sneakers that made by Puma in the output, we have to use the and condition. In this case, if you want to have a Puma sneakers in the output, which means if you want to have the true version in the output, both of these should be reflected in the output. So we are just gonna have, we just want to see the sneakers that made by Puma. In this case, you have to put the sneakers and Puma. But what's gonna happen if I put or here? all the sneakers. So in this version, it's gonna go through the first all the sneakers regardless of the second condition, and then it goes through the Puma condition regardless of the first condition. So in this case, we will just have the sneakers that is Nike, or sneakers that is by Apple Bottoms, whatever. The sneakers that is Adidas, okay? But if we just put the and condition, we will see that we will just have sneakers that made by Puma, okay? So the same that I showed you. If you put or here, you will see they're gonna have either of each. It doesn't matter. Is it a sneaker or Puma? It's gonna be whatever related to the sneakers and also whatever related to the Puma. So let's run this one. And instead of telling you what it is, I just need you to read the code for me and tell me what you expect to see in the output. Okay, someone read it for me, please. Line by line from the first line. Yes, please. Mhm. So technically, what you're expecting to see are those black sneakers and whatever shoes that created only by Nike. Okay, so the things that are important here is the order of the execution. So in this case, always SQL first goes to the and condition, then it goes to the or condition. So that's the general order. First start with not, and then and then or. Okay? Okay. So in this case, we can see that here, simplified sales type by manufacturer Nike, but first condition is black sneakers or whatever related to the Nike. So in this case, let me just run it for you. So we can see that, okay, there are sneakers black, but made by Adidas, you see? So it doesn't have to just be black sneakers that made by Nike. But we can see that the Nike, uh, all the Nike that we see here, because of this condition, are black sneakers, okay? But if I put or here, what's gonna happen? Mm-hmm. Mm-hmm. Exactly. So let's see. For example, we can see the black sneakers that are made by Adidas, or I don't know. Let's just find some Nike, maybe more sense. Yeah, sneakers gray that are Nike. So technically, when we are using or, either of condition could be true. But then we are using and, both of the conditions should be true in order to see in the output. So when we work on the more example, it's gonna make more sense for you. So this one could be equal to this code. So technically same code, but I used just parentheses. Okay, so technically when we are mentioning about the order, first is not, then and then or. But if you use the parentheses, the first order is gonna be whatever inside the parentheses. If you are in doubt to use which one in which way, always use parentheses for those conditions that you would like to have as the first one. So here you can just put also the category sneakers and color black in the parentheses. Again, if you didn't have the parentheses, it worked because automatically yes.
If it's in parentheses, it's going to search for that first.
Yes. Whatever inside the parentheses has the first priority. So again, yes. What do you mean? Mhm. If we are putting and, if we're induced to, yes, these two conditions are related together. So these two conditions, this black sneakers should be reflected in the output when we are putting and for it. So, but again, if you are in doubt, if you are not make sure which one is gonna be executed first, and you would like to have, for example, black sneakers in the first one, you could put it in parentheses. But here we can see right now the parentheses is not necessary. Mhm. Yeah, it's gonna group them all together. Yeah. So okay, yes, right. So again, by putting parentheses, you can, or let's see this one, this example. Again, I want to learn from the other side. Instead of reading the query, I would like you to read the syntax and then guess what was the query. Based on my experience, this one works better for you to understand. So someone read it for me. So which condition could, I mean, is gonna execute it first? One parenthesis. So we are gonna see whatever Nike or whatever sneakers, but the color should be only black. So let's run, and we can see all the color is only black, regardless of the manufacturer name and the category name. Okay. So right now we can see if we just remove the parentheses, it's gonna be a little different. Again, Nike or sneakers, but the color could be anything, because the main point is, let me just show you. Uh, we can see also the gray sneakers here as well, because right now the execution of the order is different from the with the parentheses version. So let me back for you. Yes.
Are any words case
Case specific? No.
Yeah, like it doesn't matter.
No, no, the lower capital, it doesn't matter. Yep.
Like,
Yeah, yeah. One of the good point of the SQL. So let's let's run it together. Find the sale of all the sneakers and boots made by Nike. Try to do it on your side as well. Sale of sneakers and boots made by Nike. So select asterisk the first one, because it doesn't tell us which attributes we're gonna have. So we are gonna have all of them. From which table? Simplified table. Okay. Where, what should be in the where condition for this one? The manufacturer name needed to be addressed, and also the category sneakers and boots. So what we are gonna have, what we would like to have in the output. we just want to see the sneakers and boots only made by Nike. Okay, so in this case, for the category, we want to have just the sneakers and boots. Should I put and between sneakers and boots, or should I put or between sneakers and boots? Or because category could be only one sneakers or could be boot. If you put and together, there is no exactly you can have a boot sneakers. You see, it should be different. This one is different. Put them in parentheses. We want to have these two, and the manufacturer name could be Nike. Because again, one more time, select asterisk, give us all the columns, all the attributes in the table. From which table? Simplified search table. What is the category? Sneakers, or category should be boots. Okay, and the manufacturer name should be Nike. So technically, in this case, it goes through this condition. Whatever sneaker, whatever boots, it give us in the output. But in order to be in the output, there is the extra condition for it. The manufacturer name should be Nike. So if I put run, we can see we will have just the boots and the sneakers made by only Nike. And if we put again and here, code works, but there is no output because there is no category that is boot and a sneaker at the same time. Okay.
Does the indentation matter?
What matters?
Indentation.
The notation.
The indent-
Oh, indentation, no. Let me see what's happened. It should be. Oh yeah, I did. I don't have it. Sorry. Thank you. Yes. Okay. So let's have this one. Find the sale of the sneakers that are manufactured by manufacturers other than Puma. So we want to see all the sneakers that created by whatever manufacturer name except Puma. Okay. So in that case, we are addressing the not function and not function. Okay. So let's write it also together on your side. We are selecting asterisk whatever column we have. And I'm gonna repeat it many more times. So it's necessary for you, believe me. From simplified sales table, we are selecting something from the simplified sales table. What are the somethings? All the columns, because it's asterisk. Where category is sneakers, but the point is we want to have just those that are not made by Puma. So and not manufacturer name equal to Puma. And why we have the quotation uh, on the both sides of the sneakers and the Puma? Because they are a string, because they are literal, because those literals, if there is a text, we have to put the string. But if there is a number, we shouldn't put quotation for it. Okay. So right now we can see in the output that we will have all the sneakers that are technically created by whatever manufacturer name except Puma. And simply, if we just remove this one, what we will have? Just the sneakers made by Puma. You see? Yes.
No, like that word.
No, exclamation equal work for you. That's good because we also use the greater than less than as well. Okay, that's great. I didn't know that the exclamation works.
I didn't know it. I just tried it.
So instead of not, you put the exclamation here. You see, I learned something from you. Great. That's also a good thing to know. Let me see if it's the same exactly. Great. Works well. So at this point, but we are just using the not. That's why I use the not also. But that's great that we can use the exclamation. So let's see another example. Let's try. And not exclamation. Yes. You're saying you're exactly -1 negative condition. So here we would say manufacturer name should not be Puma. And then you're saying this one also should not be true. So technically at the end, it's gonna be like this. Minus times minus is gonna be positive. Cool. You see, that's how you learn coding, honestly. Just by challenging your brain, try to add multiple condition, multiple situation, and then you will definitely learn well. So what is this one? Find the sale of sneakers as well as sales of manufacturers that are not Puma. Sales of the sneakers as well as. Here I can say there is a or condition should be needed. We want something as well as something else. Okay. But the point is the from manufacturers that are not Puma. So technically it's similar to the previous one, except we will have or not instead of and not. Here we can see there is a or condition. When we have or condition, A or B in the output, we will see whatever related to the A and also whatever related to the B. Just one is true, it could be in the output. But when we have A and B one more time, the only thing that we will see is A, B together to be true. Okay? So here, the first condition, A condition is sneakers as a category sneakers. And the second condition, not manufactured by Puma. So those, whatever shoes that are not made by Puma, so we want both should be in the output. In this case, we only just need or. This or is as well as. Make sense? Let me know if it doesn't make sense. For sure, maybe it's a little complicated for you, but when you go on practice mode, especially on the assignment, you're gonna get more understanding of it. But at this moment, is there any doubt about these three lines? Is there any question about these three lines? Please ask. Yes. Sure. Just forget that. One condition, A condition, I want to have just a sneaker. Okay. The other condition, I wanted those that are created by Puma. Okay. This is two condition that I'm mentioning. the type of it, the category of it, and the manufacturer name. Let's say if I use OR here, in the output, I am gonna receive whatever that is related to the sneakers, regardless of the manufacturer. So I will have a sneaker that made by Adidas. I will have a sneaker that made by, I don't know, Nike. Okay, so when you're saying or, either of them could be in the out. Then on the other side, we will have just Puma, regardless of whatever related to Puma, to that specific group. We will have Puma that are boots. We will have Puma that are sandals. And also we could have Puma that's sneaker. Okay. So technically, when there is an or between two conditions, the result of each one is gonna be in the output. Okay, this is the or one. But when we are saying and in the output, we will just see those that these A and B are true in one specific row. So we will just see those rows in the output that the category is sneakers and it's Puma. We will not see sneakers made by Adidas. We will not see boots that created by Nike. Okay, that and condition technically tell us to just have the output that reflect these two conditions together. These two conditions should be together true in order to be in the output. But when there is or, either of them could be true in the output. Okay. For the not, the only things that is gonna effective, it's gonna just make it reverse. So here we are gonna, if imagine we don't have not, we would have all the sneakers in the output, regardless of the manufacturer name. We will have Puma as a manufacturer, regardless of the category. Do you agree with this one? Okay, so one more time. We will have whatever sneakers, regardless of the manufacturer name. We will have whatever manufacturer name is Puma, regardless of the category. As an example, we could have the sneakers that made by Adidas. We could have a Puma that may create the, for example, boots. But when we are adding not here, technically, we are just make it reverse. Still, we are gonna have the sneakers, whatever, regardless of the manufacturer name. But this time, we will have all the manufacturer name except Puma. We will have Nike, we will have Adidas, we will have whatever. But since we don't have, we have a not here, so technically we will just not going to have the Puma. Okay, and again, that one is also regardless of the whatever category name is. I hope it works. Good, good, good. And so technically, again, all of the syntax I'm really showing you, all the details is also in the PowerPoint. So here, this return says of either condition is true. Those it returns all the sneakers and all other shoes not manufactured by Puma. Okay, let's find sales of sneakers that are not manufactured by Puma. So just tell me what should I do in the where condition. Sales of sneakers. So I just want to see just the category of the sneakers are not manufactured by Puma. First of all, do we need and or here? And because we want to just see the sneakers ignore the not here. That's just manufactured by Puma. Okay. Since we have not, easily we can just add one not to that one. So technically the same code, but this time instead of or, we have and. Right now, we will have whatever sneakers that created by whatever manufacturer except Puma. So just the Nike sneakers, Adidas sneakers. So do you agree if I remove the not here, we will just have the Puma sneakers in the output? There is two conditions. One condition is category sneaker, one condition is Puma. There is an and between these two. So we are just going to have the sneakers that made by Puma. So now we have just Puma sneakers. Good? Great. So again, just the rules I mentioned. First, not is going to be the first priority, then, and then, or. Again, if sometimes you're not sure enough to use which one, always use parentheses. Let's read this together. So we are selecting whatever column from the simplified sales table. There is two conditions here. The first condition, the category should be sneakers or boots. Okay, that's the A condition. And then the second condition, the B condition, manufacturer name is Nike or Puma. So technically, read the query in English for me. What's gonna be the query? What was the question for this one? We are technically asking questions from the database, exactly as you mentioned. So those sneakers and boots that are not created by one of these two. Okay. So right now we technically we shouldn't find any sneakers that made by Nike or Puma, or we shouldn't find any boots that made by Nike or Puma. For example, the boots is this mark, Siberia, or the sneakers is gonna be Adidas. And also, we will just see the sneakers and boots in the outputs. You agree with why we are just gonna have the sneakers and boots? Because in the category, we just addressing these two together. And technically, we are expecting to not see Nike or Puma in the output, which we are not gonna see any of them. Yeah. No, there is no case sensitive in SQL. But yeah, for the boots, for the sneakers, for the Puma, it should be if that's case that's. Let's check. It shouldn't. No, even that one is not case sensitive. No, no. Yeah, I just had it out. I said let's check it first and then talk about it. For example, if I put whatever, I don't know, sneakers, it doesn't matter. So now there is also another operators that we have equal, greater than, less than, that we can use it as a not equal. And he just found it explanation also is the same, but again, equal to, not equal to, less than, greater than, less than, equal, greater than, equal. The only thing that important here when you are typing on the code for the less than equal, that should be this way, not this way. It's wrong. So first, less than equal or greater than equal. We will see. Imagine you are asking question from your database, from your people. Okay, give me the list of the sneakers that made by Puma that, for example, sold in New York City, that the price of each pair is less than $50. So in that case, you have to add this condition that the price is less than 50. Do we need quotation here? No, since this literal is the number. Okay, so let's see the example. Again, just emphasizing, just by looking here, looking this syntax here, you're not gonna learn SQL. You're gonna learn it for 1 minute or 2 minutes, even until, I mean, at the end of it, at the best case, by end of this class. Tomorrow you don't remember anything. You have to just do the coding. You have to just type it. The worst case things to do is just a copy paste. I have one that I'm doing right now, but I'm just doing in terms of timing that we have. For yourself, if you are gonna practice it, okay, read it, but try to type it by yourself, please. So here, what we are, I mean, let me just close whatever extra desktop I have. So what is this condition? Just price is less than $50. So we can see price is less than 50. Less than equal. So you see equal less than is error. Equal should be, I think, no, it's not gonna work now. So, or for example, this is just give us the equal version, okay? The only things that important here, when you are having the range, the price, for example, greater than 50 and less than 100, okay? In that case, you have to repeat the price twice. So, for example, this one, is gonna give me the price over $50, not 50, over 50. And the price less than equal to 100. Again, the only thing matters here, you have to put the price twice. For each condition, you need to address the column name. So easy, we can just have the whatever above 50 and less than 100. Any question? Good, easy, piece of cake, easy peasy. So let us start. Oh, that's also this one is also fun to learn. So here we are having all the columns from the simplified sales table, where the category is the sneakers, the category is sandals, and the color is not gold. Okay, so this is one way to write the code. So we will have all the sandals, all the colors except. What is the another way to write this code? Is not what? And not change to the equal. So right now we will have, yes, we will have the sandals that the color is not also gold. Okay, so technically the same code. Instead of using greater than equal as a not to, we are using the and not and change that one to the equal. For the exams, for the assignments, it doesn't matter which one you use. At the end of the day, the number of records that are produced is important. So let's now go to something more fun. Chapter the part 2 of the lecture, which you have the file on your D12. So far, whatever we talked for this SQL that we ran, we just used one single table. The table name was simplified sales table. There are multiple information, multiple column to it. Okay, that's it. Now, the next 5 or 6 slides, I'm just going to give you one example and you will definitely understand what does it mean by it. So imagine there is a sale table, okay? In the sale table, there is a first name, last name, let's say item name, rest doesn't matter. I, as a customer, Hossein Mohit, purchased item 1. Your name, initial. What is your name, initial? No. MS purchased item 2. Your name, initial. CG purchased item 3. Okay. Again, Hossein Mohit purchased another item. Okay. Now imagine you are working in a company like Amazon, and then these rows could be millions in just 1 month, 2 months. So now imagine each time the operator is gonna input Hossein Mohit each time for each number of transactions that we have. Is it ridiculous or not ridiculous to you? It's ridiculous. Waste of time, waste of energy, just occupying extra space in your hard drive, cloud drive, whatever. Okay? So, and just imagine they have some mistake on my name. And after 1 month, they will find, okay, his name is not Hossein, his name is Michael Mohit, whatever. Okay? They have to go back and just read all the data and change everything. But there's a simple solution for it. Okay, this is the cell table. Let's remove the first name, last name here. Let's put customer ID here. Let's create another table, name it as a customer just once. Customer ID 1, the name is Hossein Mohit. Customer ID 2, the name is CG. Customer ID 3, the name is MS. Okay. Now, the only times that they need to put my name there in the system is just once. And then, whenever I, Hossein Mohit, purchase something, my ID is 1. If they made a mistake, they will just come back and just change it once, and it's gonna be okay. So why I'm mentioning this one? Technically, in the database, you need to have multiple tables in terms of addressing your database. That's what we call it as a normalization. We will talk about the normalization process, chapter 3, chapter 4. But right now, with just this example, does it make sense why we need to have multiple tables in the data? Each table, which technically by table, just let's go back to the first example of our class. The book, the author. Okay, the book has its own table with the attributes author has its own table with the attribute. Okay, so technically, each table, whatever attributes is in the table, should reflect the most efficient way to reflect, explain that entity. If it's the book name, for example, it doesn't matter which transportation company, I don't know, transferred this book from this storage to that storage. The only things that matter for book for me is to the book name, the publisher name, I don't know, the author's name, whatever, as much as related to that one, as much as more detailed that one is better. So extra information, it's create redundancy. It's create extra information in the data, extra information in the data, extra storage, extra waste of time, extra everything. So you have to be as much as efficient as possible. What does it mean by efficient? We will learn later. When you are creating a table, even the number of characters that you are assigning to the first name is important. 5 characters, 8 characters in the millions of rows of data, it makes huge difference. So that's why we have to just make it as much as possible, efficient as much as possible. Okay, so technically, the rest of this couple of slides is just for explaining why we need multiple tables. Right now, in the Red Cat 1 datasets, the one that we are already working, there are multiple tables. So the tables that right now, for this moment, we are gonna work, we are gonna have the sale table, all the information related to sale. Then the customer table, all the detailed information about the customer, whoever it is. Product table and the manufacturer table. So right now we are trying to create some queries from multiple tables. We are not working anymore on just one single table, which is not reasonable at all. Whenever you are going to work with a database, you are going to at least deal with hundreds of tables sometimes. We saw that incident graph for the insurance at the, I think, session 1 or session 2, that multiple over 10 or 20 tables was in that one. So imagine you are dealing with some bigger company, bigger table, number of tables, and also the rest. So this is how we will address it. This one, we will talk about it. It's a ERD, entity relationship diagram. We talk about it. The example that we had, if you remember, we said, okay, one table for the faculty, one table for students, one table for the class room or class, the course, let's say course. We mentioned that every faculty could have multiple classes to teach. Every student, they can attend to multiple classes, one-to-one, many-to-many relation. We'll talk about them in details later. But for now, we call these as an entity. And the relationship with this entity, we are showing here. We call this as an ERD or entity relationship diagram. If you already passed the system analysis and design course, you already saw this ERD over there. But we are also again cover it in this class from the different perspective. So right now, we have the sale ID. What are each cell telling us? What's the name of this specific cell? Features, attribute. Each table, we call them as an entity as well. So we can see there are some key next to some specific cell. Do you think what are these? What are these key? Exactly. Each table, they should have one unique identifier in order to address in the database. Okay? Here, the cell ID, when you change the cell ID, the rest of the information is going to change. So the unique identifier of this one is cell ID. Why that's unique? can we say that the sale date is unique in this one? We can have multiple items that sold by April 15 of 2024. It's not unique, but the sale ID 1 is unique just for one transaction. Sale ID 2 is unique. How about what do you mean the hash? You mean the hash coding? Exactly, exactly. This one exactly represent this table. That one for this table, customer ID represent the customer table. The reason for that, if I tell you postal code 30066, it doesn't pull up the information of the customer. It could be thousands of customers that has the same postal code. But if I tell you the customer ID 2, you can just easily search and find the customer ID 2 is Hossein Mohit. Okay? So each customer has a unique value. Same here, same here. So this is the what we call it as a primary key. If you work with the access so far, you will see that in the access you have to assign the primary key, and there is a golden key that usually shows in the data in the screen of the access. But there is something in common between these tables. For example, between sale and the customer table, what is in common between these two? Customer ID. Customer ID is the primary key of the customer table. Am I right? Keep it this one. Product sale table. What is in common between these two? Product ID. Product ID is also a primary key of this table. Correct? Manufacturer table and the product table. Manufacturer ID is the primary key of this table. Technically, the primary key of one table is considered as a foreign key of another table. We call them as a foreign key. That's fine. So technically, customer ID is the foreign key in this table. And we can see that we can have multiple foreign ID. Imagine at the place that I am standing right now, this is the sale table. Here, this is the customer table. In order to go from this table to this table, I have to find a path. I have to find a bridge. The bridge is the common keys between these. If I want to connect these two tables together in the SQL code, the only way to connect these two tables is through the customer ID attributes. Now, how you can connect the customer to the product table? Directly. Customer ID to product ID. Customer table to product table. No, directly. There is no way. Whatever I ask is not important, is not correct. There is no common key between these two. You cannot connect these two tables together. You were mentioning right. If you want to go through this one to this one, you have to address in that. So that's the way that, again, one more time, we will see in the example. I'm just saying, when you're writing the SQL code, technically you are transferring your simple English to the SQL version. So when you are reading the query, when we are talking about our course, when you're reading the assignments, when you're reading the quizzes, when you're reading the exam questions, according to the keywords, you have to find out which tables I'm going to address. If the keywords, if the queries asking me the number of customers that purchased, just number of customers, giving me this idea, okay, I have to address something in the customer table. Purchased is the sale. Some item that manufactured in New York City, manufacturer is here. So I have to address this table. We will see example, yes. Yes. So technically, for example, yeah, if you change the manufacturer ID, it's gonna be update everything else. Yeah, yeah. That's the main part that I was mentioning. Hossein Mohit. If I put Hossein Mohit millions of times, waste of energy, waste of time, waste of everything. But if you have a table, Hossein Mohit, customer ID 1, if you change Hossein Mohit ID, whatever, it's gonna change in the whole data set. Technically, you will understand better when we see the exam, when we see the questions, examples. But at this moment, the only thing that I wanted to tell you is about the primary key, foreign key, of how these tables are connected together. And I hope I did a good job. So the rest of the information for it. Now let's write a join query. Okay. So we talked about the select, from, where. We will talk later about the group, having group by, order by. But right now we are talking about the something new as the join. Okay. Now let's read this syntax together. Again, we are working on the MySQL database and the Redcat credential. So read this one for me. This is your first time seeing this code. If you can't read, it's totally fine. But just according to what I already explained, tell me what you think. We are selecting all the attributes. Let's go line by line. From sales table. Then we are going to the product table. What is the bridge between the sales and product table? Sales and product table. What is the bridge? Product ID. So technically, I have to say sale dot product ID. This one means product ID from sale table. It should be equal to product ID from product table, where category is a snippet. Technically, what we are going to have in the output is just the items that the category is sale. But right now we don't have one table anymore. We have multiple tables. In that case, we have to address two tables together: sale table and product ID. And we can see right now there is something in the output. First, the first table, sales, is sale ID to the sale price. We can see sale ID to the sale price. So this is the table output from the table 1. This is the columns from the table that we call the sale table. Agree? Yes? Yes? Confirm, please. So now, again, the second table starts from here. Product ID to the description. Product ID, product name to the description. And we can see here we have the product ID twice. Make sense? When we are saying select asterisk, technically we are requesting whatever column in the table. When we have two tables, so we are requesting whatever columns in these two tables. This is the issue that we have right now, that we have two product ID. But the main point is, until this part is from the sale table, the rest is from this one. The only way that these two could address together is a product ID, 1232, 1232. Again, 1232, 32, and the rest, whatever we have. So let's just, I don't know, 1235, 1235. This is the only way that these tables are connecting together. Okay? So let's see another example. Right now, just let's learn the logic one more time together. Sale table, product table. It has two columns, sale ID, product ID. It has two column, product ID, product name. If I am joining these two tables together, how many columns, how many attributes we are going to have in the output? 4. Sale ID, product ID, product ID, product name. Okay. How many records, how many rows we are going to have in the output? Let's do it together. Sale ID 1, the product ID is 10. Do we have product ID 10 in the product table? Yes. What is the product name? XXX. So that's the first row. Sale ID 1, product ID 10, product name is XXX. And we can see a sale.product ID, product.product ID, which means product from the sale table, product ID from the product table. Make sense? Let's go to the second one. Sale ID 2, product ID is 20. Do we have product ID 20 here? Yes. What is the name? Y. So 2, 20, 20, Y. Again, sale ID 3. What is the product name? 10. Do we have product ID 10? Yes. Name XXX. Done. We don't need product ID 30 here because technically product ID 30 already is not in the sale list. Okay? So the same explanation I mentioned is here. Yes. As it in this specific example hasn't sold yet. Now let's read this together. If you tell me this one, we are almost done by today. So what is this one? Read it for me, please. The only things that matter right now is the first line. Select all columns of the sales table and category and price. So what we are going to see in the output is whatever attributes, whatever columns in the sales table plus category and the price from the product table. And then from the sale table, we are joining to product table. What is the path? Is product ID where category is sneakers. You might have some questions why we mentioned sale here, but we didn't, for example, mention product here. Let me first run this one. So right now we can see we will have just the sneakers, okay? And we will have sale ID to the sale price and also category and price. We know that the category, okay, and the price of the item is just only in the product table. So we can also address this one as well. So technically, we are having category from the price, from the product table, price from the product table. Make sense? If I run, same output. But why we don't need it to put it here? Because category and price is just available in the product table. It's not in both tables. If it was in the both table, we had to address it. There are some different opinions for it. Some people would say always address which attribute comes from which table. In that case, you are learning better, and then later you are not going to have any problem. Some people, they would say, no, there is a waste of time because we know that just the category and the price is only available in the product table, so we don't need to address it. Category and the price. Yes, and the price. And this is the way that we can address it. Sales dot asterisk. When we say sales dot asterisk, technically we are calling whatever attributes in the sales table. Okay. let's stop here. The next step is going to be joining three tables. Technically the same. When you know the rules, it doesn't matter. 2 tables, 3 tables, 4 tables, 10 tables. It doesn't matter. Just let's read this one together. List sales of sneakers made in New Jersey. That's why I'm telling you exactly translating your English to the SQL. List sales of sneakers. So it's telling me you have to deal with the sales table. Okay? So there is a sales table. Sneakers, giving me the information that I'm talking about the product. Sneakers is available in the product table also. And made in New Jersey, again, giving me this address that I have to go through the manufacturer table. So technically, let's just read it together. We are selecting, let's say, all the column. It doesn't matter. Just select asterisks. Whatever you have, it's going to be in the out. Or you can, for example, say sale ID from the sales table. I don't know, product ID from the product table, CD from the manufacturer table. It doesn't matter. Let's say select asterisk from which table? From sales table. We are joining to product table through the product table, product ID. Then join product table to manufacturer table through the manufacturer ID where the state is New Jersey. So we can just see this is gonna be the syntax. So select here, we are having all the columns from the sale table, agree. Select sales dot asterisk, which is all the column from sale table. Category, manufacturer name, state. Since state is only available in the manufacturer table, so you don't need to address it. But if it was in a different table, you have to. Okay, that's fine. From sale table, join product table. We were in that stage. Sale table to product table. On sale dot product ID equal to product ID, then joining the manufacturer table to product table on manufacturer ID, where category is sneakers and state is NJ. So technically, we are just having the sneakers that only created by in New Jersey. Okay, so have a good rest of week. I will see you Wednesday. So we will start about the joining three tables again. Let me stop sharing, stop recording. Okay, so welcome everyone to second part of the lecture, week 4. So today we are gonna finish chapter 2, and then next week chapter 3, and the next 2 weeks we are gonna have our first SQL exam. So technically by end of today, you are gonna have whatever you need for this first SQL exam. The only things that you need to know and you need to do is going through the assignments and practice those assignments and quizzes that you have. So no questions so far? All good? Okay, so let's just have a very quick review about what we discussed on the previous session. So we started with this fact that we start chapter 2 with working on just one single table. And then we talked about it, why we need multiple tables in a real databases. We had those examples of, for example, having just one table with my name as a customer. And for example, if I have thousands of transactions with the company, they have to put my name for 1,000 times. And if there's a mistake for it, they have to fix it for 1,000 times. We said, okay, the best way for fixing this solution to have a separate table as a customer, put my name there, give me the ID for my name, and then we are just using my ID instead of my name in the table. So that's why we needed multiple tables in the real data sets. And we mentioned that this action, we call it as a normalization, which we will talk about it on chapter 3 and chapter 4. So we've been through some of the so we've been through some of the syntaxes for running queries based on the single table first, and then we went through the multiple tables. So let's just have a quick review about this code. So what this code tell us, just some of you please read this code for me one line by line and explain what this code means to you. We are selecting all the columns from the select table, and so these are the columns that we are going to see in the outputs, all the all the columns from the cell table and the category and the price. And then so we are starting from the sale table. We are going to product table. The way the path from sale table to category table is through the common attributes. We call those attributes first. We mentioned what are the attribute means, and then we said each table, they have to have the unique identifier. For example, for the sale table, we call it sale ID. For the, I don't know, product table, we call it product ID. And then we call them primary key. You remember that? The primary key that we discussed 2 days ago. And then we mentioned that the product of the ID of one table that available in another table, what we call it? Foreign key. We call it as a foreign key. So for example, right now, the product ID, which is the unique key or primary key of the product table, already existed in the, where is the tables? So here. So we can see that the product ID, that's the primary key in the product table, is the foreign key in the sale table. And these two tables are connected through the product ID. And then we, after running this one, so technically we are having just the output for the category sneakers. Okay. And then we had some explanation about it. And then we've been in that stage. So let's start from this stage. Now we are talking about the joining to three tables. And the rules are the same. There is nothing special. There is nothing big deal to it. Just one extra line we are going to add to our syntax, our code. And we mentioned that for running the queries, you need to just translate the English to the SQL language. You need to translate whatever case that you are going to deal next in your career, whatever they ask you, the helper asks you, and you need to just translate to the English, to the SQL. So right now, list sales of the sneakers made in New Jersey. So based on the keywords in the queries, we can find which table we need to deal with. So right now, list sales. At this moment, we just understood, okay, and we have to deal with the sale table. And then the sneakers. So we are talking about the products. So let's also have the product table as well. And then made in New Jersey. Made, which means we are dealing with the product with the manufacturer. Agree? You all agree with that? So technically, we are dealing with these three tables. In these three tables, the common key between the sale and product ID is sale and product table. What is it? What are the common key? What are the common attributes? Product ID. You all know it, please. Product and manufacturer table. How we can connect these two tables together? manufacturer ID. Great. So technically, we are just adding again one more line to the previous code. So right now we can see that we are going to have all the columns from the sale table. Am I right? Because sale.asterisk, which means all the columns from the sale table. Category, manufacturer name, and state from the whatever table that they are related. Okay, we are not mentioning from which table, because already in our data set, state is just available in the manufacturer table, so we don't need to mention it. From sale table, from the sale table that we see here, we are going to product table through the product ID, right? Right. So from sale, we are joining product table on sale.product ID, product.product ID, product ID from the sale table, product ID from the product table. So that's the first part. The second part, we are going from the manufacturer table to product, or vice versa, it doesn't matter. So now we are joining the manufacturer table on through the which road? Manufacturer ID. So right now on product.manufacturer ID equal to manufacturer.manufacturer ID, where categories is sneakers and state is New Jersey. Do we need and, or do we need or in this one? So do we need and or in this one? So let's go one step back. What does it mean when we are talking about the and? What does it mean when we are talking about the or? When we have A and B, A or B. So what are the output of these two? So technically, we need to satisfy both conditions. So we are gonna definitely see A and B in the output. And the second one, either could be true. So we can have just A, we can have just B. When we are talking about the sneakers made in New Jersey, okay, it's asking us sales of the sneakers made in New Jersey. It doesn't ask us sales of the sneakers as well as whatever other shoes in New Jersey. So in that case, we just need to see sneakers that made in New Jersey. That's it. So the A condition is sneakers, the B condition is New Jersey. So we need an and for it. And then we are gonna see just the New Jersey sneakers. Okay? But then we are saying sneakers or New Jersey, we are going to have whatever sneakers, regardless of the state that they are produced. And then we are gonna have whatever sneakers that create just in New Jersey, regardless of whatever, shoes, regardless of that sneakers, boots, whatever, sandals, whatever. We are gonna have all the type of shoes that made in New Jersey. Plus also all the shoes, all the sneakers that created in other states. Okay, so that's the and or. I am 100% sure that you know, but I don't know why today you are a little so shy to just make some comment. Please get involved. So we can see again, after running this one, we are only having sneakers that made by New Jersey, made in New Jersey. So if I just change it to or, we are gonna have sneakers which also created in California. And if I go through the other pages, we are just seeing the 100. For sure, we are gonna see the state New Jersey, which boots are created there. I don't know, sandals are created there, whatever shoes. It shouldn't be just sneakers. So that's the difference between the and or. You remember, right? So there is an option for us to try to make the syntax shorter. I will mention that always it's better for us to have as efficient as possible for the syntax. We call these techniques using the alias. Okay, so by alias, just very simple rule. For example, instead of product table, we would call P. Instead of sale table, we call S. You can use N for the product table, but for sure it's easier for us to just use the first letter in terms of not having mistake. But how this one works? So same code, list the sale of the sneakers made in New Jersey. But when you are going to use alias, ignore the first line, ignore the select line. Let's start from the from, okay? So you would go from sale, you're going to sale from the product table, to product table. So sale to product table for the first line, and then a product to manufacturer, okay? So easy. From sale, space S. It means that from now on, whenever we are gonna address sale, we will just put S instead of sale. Join product. Product is new right now in this code. So for the product, we will just put P. Then when I'm gonna join it, these two tables together, I'm not gonna say sale.product ID, P product.product ID. I will just use s.product ID, p.product ID. Yes. Join, okay. So we started this chapter just working on one single table, okay, which was simplified sales table. You remember we had some columns. And we mentioned that, okay, we start with this one. We start with this most simple syntax, select asterisk from simplified sales table. So the output of this syntax is all the column of the simplified sales table, okay? Then we explained in a real world, this is not the case. You are not gonna have just only one table in the organization, in whatever database you are working. As an example, I mentioned about the sale table that my name is there as a Hossein Mohit, first name, last name, Hossein Mohit. And I mentioned that, okay, if I purchase thousands of items in a year from this company, each time they have to put Hossein Mohit there for 1,000 times. And first of all, it's a waste of energy, am I right? It's the waste of the space in your databases, am I right? If they make some mistake on my name and instead of, for example, Mohit, they put Mhit. If they want to fix it, they have to go back and fix it 1,000 times, right? Okay, so we mentioned that in this case, it is better to have another table, which we call it customer table, okay? This is all related to the join. That's why I'm just repeating again. So in the customer table, they are give me customer ID 1, who is 1? Hossein Mohit. And then from now on, in the sale table, they will just use customer ID for all of my transactions. So technically, they are just entering my name once instead of 1,000 times better. If they put my name wrong, they can just fix it once, you see? So that's why we need multiple tables. That's it. So right now, when we are having multiple table, we have to go through tables to the other tables in terms of asking queries. The join function that we are using, technically, we are joining two tables together. Then 3 tables, then 4 tables. Each time through the join function, technically we have to address through the common keys between these two tables, right? So right now in these two tables, the common keys between these two tables is product ID. We have product ID here. We have product ID here. So whenever I want to join these two tables together, it should be through the product ID attributes. Okay, so back to your code. Technically from sale table, we are going to product table. For going to, we are using the join syntax. That's the meaning of join. That's the purpose of using join in the syntax. So if you go through all the queries in the chapter, in the book, you're going to have multiple examples, and it's going to probably make more sense for you. Still, have you have any questions? My office number is open to you. Just send me an email, and we can talk about it. So we were in that stage that we were talking about the alias. Nothing new. Again, ignore the first line. From sale, S is gonna representative of the sale from now on. Product P is gonna be a representative of the product. So on, instead of sale.product ID, we would say s.product ID. This is the third line. We were supposed to go to the manufacturer. Manufacturer, we just use M, and now on the rest of the code, instead of mentioning product.manufacturer ID equal to manufacturer.manufacturer ID, we will just call p.manufacturer ID and n.manufacturer ID. Easier, less mistake, less coding, so it's good to have it. And then for the first line, for the select, here you cannot use sale here anymore. You have to just use the alias. That's the rule. Right now, if I run this code, the same result that we were supposed to have, just shorter code. But if I use sale here, we are gonna have error. Okay, because the sale right now in this code, we are technically mentioning that the sale is S. Sale is not sale anymore. So that's the only point of using alias. If in the questions, in the exams, in the assignments, they ask you to use the alias, you have to address it with the alias. Otherwise, you don't need to do it. But in your regular coding, later, it's always good to use alias. It's gonna make your code shorter. And just having some typo, it's gonna avoid whatever probably typo that you could have in your syntax. Okay? So that was the purpose of using alias. Another example. Read the query to me, please. What we are going to have in the query, just read the English. Okay, so now just imagine we don't have this table or something, that sounds. So right now we have to find the keywords in the query and try to see which tables we are gonna address. That's another example, nothing new. So list products, technically it means we are going to use the product table, right? Sold, just sold, the keyword sold is enough for us to know that we are dealing with the sale table as well, okay? The customer living in Illinois. So the customers, technically we are dealing with the, which table? Which table? Customer table. So in that case, we are dealing with these three tables. The common key between these three tables, the customer and the sale, is the customer ID, product, and the product sales again is product ID. So what we are gonna start with the select, whatever column that we need to have from sales table. We are joining to which table first? We are joining to, let's say, product table, sale to product, That's the logic of the code. And again, join another one, sale to customer, where what was the condition? Customers living in Illinois. So state should be Illinois, right? So, and please do the coding on your side. Just don't look at the screen. It doesn't work for you. So right now we can see that the product name, okay, from sale table, sale, we are calling it with just S as an alias. There is no need for that, but again, it's good to have it. We are joining to product table on through which path? Product ID. So p.product ID, s.product ID. Join again to customer table. We call the customer table C on s.customer ID, c.customer ID. From where, which condition, where the state is Illinois, from the customer table. So you tell me, if I remove this C dot here, let's first run it. If I remove the C from here, what's gonna happen? Are we gonna have any problem in the code, or it's gonna work? It's gonna work, sure, because states is customer table. There is no state here. So technically the syntax, when it sees data set, it will see, okay, right now in these tables, which means sale, product, and the customer, state is only available in the customer table. So if I just remove it and run it, still the code works. Cool? Question? No question? Sure. So now let's have another example. The example of the for table. List products made. Just by these two, we can see, okay, the product, we are dealing with the which table for the product? Product table. Made in New Jersey. So which table we are dealing with? Made, manufacturer table. Sold, sale table. Customer, customer table. So technically we are dealing with these 4 tables. So right now, it's still the same code, just one more extra line. We are selecting product name. We use the distinct because we don't want to have the duplicated value for the product. I don't care. I just want to know the product name. It doesn't matter. It's 2 times or 3 times. It doesn't matter. From sale table, okay. For the sale, we are using S as an alias, right? We are going to product table through which path? The product ID. Then we are going from the sale table to customer table through which path? Customer ID. And then we are going from product ID to manufacturer table through which path? Through manufacturer ID. So just one line extra. Where the state is in the customer table, Illinois, in the manufacturer table, New Jersey. Here, if I remove these two, we are gonna have problem because right now there is 2 states in this example. One state is on the manufacturer table. One state is on the customer table. The question asks us, product made in New Jersey. So technically we are dealing with the states New Jersey in the manufacturer table, and then customer in Illinois. So we are filtering the result for the customers in the states of Illinois. Okay, so that's why we need to have it in this specific example. And if we don't have the alias in this one, the code is gonna be a longer. So we have to put customer here, we have to put manufacturer here. Also the same for the other PM as all the things that we have. Any question? Nothing? Yes. There's the indentation is not necessary. When I just, yeah, just weird. That's maybe just. So you see, there's no difference. That's when you just copy and paste it automatically it's gonna paste it in that. If you have even one small questions for this syntax, please let me know. If you need me to explain one more time, please let me know. Yes. Sure. So here, let's go through the question first. The query, my boss asking me, go and do this. What is this? You have to give me the list of the products that made in New Jersey and sold to customers in Illinois. That's the case study. That's the case that they're asking me to have. One way is go through the different tables in the data sets that I have and do this manually. And probably you can do it in the next 2 or 3 years, right? So that's why we have SQL. We have this type of query languages. So we can just ask the table, the data sets to give us the result in a fraction of the time. So in this case, I have to know which table I am going to refer for answering this question. That's why I have to go through the keywords in the question. It asks me list the products. Okay, by list products, I can just quickly understand. Okay, I have to work with the product table. I have the product table, which is the product ID, product name, manufacturer ID, category, color, price, description. And then made in New Jersey. I will think about it and see, okay, made in New Jersey, which means I have to deal with some table that has the information related to the manufacturer, the people that they are producing this product for me. So that's the manufacturer table. Sold to customer in Illinois. When I'm talking about the sold, which means I have to deal with the sale table. So sale table has all the information related to the sale, right? And the customer in Illinois, so which means I have to deal with the record of the customers. Where are those customers records? They are in the customer table. So far we could understand these 4 tables we are dealing with. Now the next step, let's find what are the common keys between these 4 tables. Sale to customers tables, we are just looking. Customer ID is the only common key. If I am trying to use the join function, if I'm trying to join these 2 tables, the only way is customer ID attributes. That's it. Then sale to product table. The only way is product ID. Then product to manufacturer table. The only way is manufacturer ID. So now you tell me, how can I connect customer to manufacturer table? Directly. Is there any common attribute between these 2? Customer ID, first name, last name, street address, city, state, postal code, country, phone. Here, manufacturer ID, manufacturer name, address, city, state, postal code, phone. We have the phone, but the point is this phone is for the customer, this phone is for the manufacturer. That's a different thing. The only way that we can find a common path is the primary key of one available there as a foreign key. Right now, the primary key is sale ID. Do we have any sale ID here? No. But the point is, we have the product ID as a primary key. That one is available here. This one considered as a foreign key. We have customer ID as a primary key. This customer ID through this table. Here is the foreign key. Here is the primary key. Again, manufacturer ID, primary key. Here is the foreign key. So technically, that's the only way. So the primary key of one should be available in other table. That one considered as a foreign key. That's the only way that you can connect two tables together. So just by only having the phone or only having, for example, I don't know, estate, you cannot connect two tables together. It should be a unique identifier of one table available in another table. That's a rule. Primary key of one table available as a foreign key in another table. And that's a great question. So that's the point. Now, after all these, after finding of which tables we are dealing with and which keys we have to address these tables together, here the part that we are going from the sale table to product table through the product ID. Sale join to product through the product ID. Then sale to customer table through the customer ID. And then product table to manufacturer table through the manufacturer ID. And we are just using alias in terms of making the code shorter. That's it. Looks better? Yes. On the select line, you can use the alias, but yeah, you have to just use the alias. You shouldn't use the table name. Okay? Again, coding, which means practice, practice, practice. You have to go back home after this session, and I would do that because next 2 weeks is going to be your first SQL exam. Okay? You have to go through all of the syntax that I wrote in the class. They are available in your PowerPoint, and also they are here. So you can just go through each one, run it, see the result, do whatever changes you want, change the indentation, change the alphabetic, the lower, I don't know, upper. So just play with it. Okay? And again, one more time, we are in week 4. I don't care about your grade. The only things I care is just learning the SQL. SQL, which means just practice. Coding, which means just practice. Okay? So just look at it as a fun. Don't look at it as a just passing this course. That's the only way you can learn. Otherwise, you are just gonna pass this course, and next 2 months after this semester, you don't remember anything. Just believe me. Okay, so I hope I answered your question. So that's the fourth table. Before starting the last part of the lecture, let's finish the last part of the lecture, and then we can go to the assignments. So we created the database. We have a database. We are asking questions from the database. We are asking queries like the customers that purchased, for example, sneakers in New Jersey, whatever. So right now, that's the time that we need to understand how we can update the database, how we can insert new data to the database, how we can delete or drop a table or a specific row of data from the database. That's the time that definitely is the one of the most important part, because you are adding data in your database second by second. So that's the data is generating. You have to just address it in your database. Okay, so stay with me just for at least 1 minute and listen to me very carefully. Right now, we are working on the Red Cat 1 database. This database already created by the MyEducator. Tables are there. We are asking queries. At this moment, we are gonna work just on your credential, your student credential, okay? In this one is only for you. So you can just create table there, you can remove table there, you can add whatever. The main point is if you work on the Red Cat one and for example, remove one table, this one, I hope you haven't done, okay, does your face look, oh my God, I did something. Yeah. Mm. When we are talking about the drop, for example, product table, if I run this syntax in the Red Cat one, the product table in the Red Cat one is gonna gone forever in your database. Okay, so you shouldn't do it. We are gonna talk about it. So whatever we are dealing right now, we are working just on your student credential. That's the space only for you. You can just add whatever table to that one, remove whatever. Okay, so this part is the most easiest part. Let's do it very quick. There are three functions for it: insert, update, delete. You can insert, there is a table, let's say customer table, first name, last name, whatever. Each rows are records. The first row is Hossein Mohit, second row is CJ, third row is HM, whatever, or HN, whatever. Okay, so sometimes, not sometimes, always, I want to add some customer to the table. So that's the part that I have to use the insert function. Sometimes I want to delete something from the rows. That's the part I need to use the delete function. And sometimes I need to update. For example, the Hossein Mohit marital status is single. Now it's married. I have to change it to the married. So I have to update it. So that's the way that we can use the update function. So also we can insert one single rows, or we can insert multiple rows, or delete or update, whatever. So we will talk about it. So let's start. Let's go directly to the book. Open your chapter 2 on the 2.4. Okay. In this part, the first box, which is the drop table my customer. Okay. If you haven't run it so far, okay, like the one that I'm running at this moment. But before running, don't push the wrong query. This table, this syntax, just let's read it as English. The first line telling me drop table. What is the table name? My customer. My customer is not created yet. So I'm expecting if I run this code for the first time, I'm going to have error for the first line of the code. But the second line, that's the syntax we are learning just right now. We are creating table. What is the new table name? I am naming it as a my customer, as technically I am just copying from the customer in the Red Cat database. Customers from Red Cat database that I have. Okay? So for whatever reason, which I don't know, if you change this Red Cat D to Red Cat, also works. I don't know, something is probably wrong with their database name. So Red Cat D is the default name. But again, if you change it to Red Cat without D, it also works. Where customer ID less than 100. So technically, I'm just creating a new table. The new table name is my customer. in my credential, in my space, and then I'm just having the first 100 customers in that table. I have also another syntax here. Select all the columns from the my customer, show me. So technically we have three syntax here. The first one, dropping the table, create the table, select table. If you just run it right now, which I'm going to do it, we are going to have one line error, and then it's going to create this one. If I run it again, the next time, since we have my customer, so we are not going to have an error anymore. We are going to have dropping the my customer and again creating a my customer. So let's run it together. If you open in advanced editor, it will automatically show you this is on your UL. This is on your, okay, now this is on your student account. So you see, I ran it, and first line I have the error. You should have the error on your side. Am I right? So technically it says there is no customer, my customer table, which is right. And then the second part of the code, it's gonna record and create a new table, which we call it my customer table. And then with this condition, we can see this table here. Okay, so if I run it again, this time there is no error because we have my customer table. We are dropping once and creating again. So technically, the creating the table, deleting, inserting is not a big deal. The only thing that matter right now that you understand this point, that you are from this point in this following assignments, 2.3, 2.456. In those, you are just working automatically in your databases. If you are running your code in these boxes, automatically they are going to be in your databases. But if you are going to your advanced query editor and you are trying to practice this syntax, make sure to just work on your student account credential. Okay? Clear? Good. So now I created the table. So just very quick, if I put show tables here and run it, you see that my customer is created here. Okay? But if I, for example, put drop table my customer and run it, okay, and then show tables, there is no my customer here anymore. Okay, so now if I run it again, we are going to have one-time error for the first line, and then second line is going to be okay. Now after this one, it's time for us to inserting a data, the table. What is the code for this one? The code for this one is insert into simple English. The table name. What is the table name? We just created my customer, right? Now I have to address the attributes name. The attributes name in table is customer ID, first name, last name, street address, city, state, postal code, country. Then the second part of the code, which I have to mention, now it's time for put the values. So technically, so far, insert into is the first part. My customer, which is the create the table name, parentheses, all the attributes, all the column. What are their values? One by one. The customer ID, 500. First name, last name, street address, null. What does it mean by null? We have no idea what it is. It's not zero, it's not blank. We have no idea what it is. Null technically is null. It's not a missing information. We don't know what it is. Okay. If I put null in the quotation, is it okay or it's not okay? Why we are using quotation? When we are using quotation, that's better to ask. Where there is a string, when there is a name, there is a character. When I am putting null in the quotation, the syntax deal with this one, treat with this one as a character. So the system doesn't know what does it mean by John, what does it mean by Smith. Even if I put it in a string, there is no difference between null and John for the system. But when I am just putting null, I don't have idea what it was. I no idea what it is. So street address, city, state, postal code, country. So that's the way that you can insert the data. Right now, in this one, if I run the query, the second part of the code is select asterisk from my customer. So right now, I can see that the customer ID 500 is available here. Cool. Good. Should all receive the same result. There's nothing, because they are all predefined in the computers, in the machine, in the MyEducator. The only things that you need to just know, if you ignore the second line, which is the customer ID, first name, last name, street address, city, state, postal code, country. If you remove that line and technically consider it as a default, the values that you are writing is gonna fill in this table respectively. So technically, automatically, software is gonna understand, okay, the 500 is for the first column, regardless of whatever it is. This John is for the second row column, regardless of whatever it is. It doesn't matter for it. So technically, when you are putting 500 John Smith, technically you know that the 500 is the customer ID, John is the first name, Smith is the last name, whatever. Okay. If you want to just make the code shorter, you can just ignore that line and just write only values. But you need to be very careful that you don't make mistake in the order of the date, which I don't recommend. Just wanted to let you to know that there is a possibility to remove that line, the attributes lines. Okay. But this one for sure is the better one. There is also another way that you can okay, we talk about this null. That's the part that I said we can remove the column list. There is also another way that you can insert multiple rows from one table to another table. You have, for example, sale table, and now in the new table, you would like to just, for example, insert another one based on some condition. So far, in this one, we saw it. We saw that we can create a table selecting all the columns from the customer table in the Redcat data where the customer is 100. So technically, you are just importing the first 100 records of customers from the customer table. This one, you are inserting into the existing table name. Existing table name, which means the my customer that we just created. It should be already created. Select asterisk all the columns or some specific column from table with desired data, from the customer table, from the Redcat database, where whatever condition we have. For example, in this case, we are, I don't want to because put it because I think we don't have, what was the table name? Sale archive. Okay, we don't have the sale archive here. Just show you here. So technically, what this could do for us, it's assume that there is a sale archive already created. It assume that the sale already available. So technically, it's gonna insert into the sale archive table. From which table? From the sale table where sale date is before January 1st, 2014. That's also another syntax. If I want to make sure that this code works, what should I do? I should go and make sure first through this syntax. I am creating a table that the table name is sale archive, and then try to insert the rest. But just this one is also only that one works as well. This is for the case that you have multiple tables, you just want to transfer some rows from some tables to other tables. And okay. Let's have the update. So the update, how the update works. Here, right now we created the My Customer in our credential, student credential. So how the update works. It starts with the update keyword. Which table you would like to update? I would like to update My Customer table. Which specific attributes you are going to update it? I would like to change something in the last name. Okay, set last name to West. For which row, for which records of data? Which one? This one, this one, this one. Where the customer ID is 30. Okay, if I don't put where here, what's gonna happen? You're both right. It's changed all the last name to West. Okay, but when you're addressing it where customer ID is 30, so it goes to the customer ID 30 and change it to 30. Change it to the West for the last name. But imagine you would say, let's imagine we have named John West, John East. Okay, and then we would say, let's go and find whenever the first name is John and change it to the West. Is it a good idea to go through just the first name and change the last name? No, because there might be multiple John in the list, and it's going to change whatever John in the list, change the last name to the West. That's why we need to have a unique identifier for the table. Unique identifier for the table, which means unique value for each record of data. When I am addressing through the customer ID, now I am pretty sure that whatever it's going to happen, it's just going to happen only for the only rows that has the customer ID 30. Okay? And the select part of the code just show me whatever available in this one. So right now, if I run this one, we can see that the customer ID 30 is Raquel West. I don't know whether this one. So let me just run it again. Customer ID 30 is Raquel Lopez. You see, when I run this code again, updating, the customer ID 30 is Raquel West. And the delete function. Delete which means just deleting rows from the data. Simple. I would like to just delete from which table? My customer table, the one that I just created, where the customer ID is 500, where the customer ID is less than 100. So it's going to delete all the customers that ID is less than 100. Where the production state, the manufacturer state is Illinois, it's going to delete all the manufacturer IDs, manufacturer that are Illinois. It's going to record all of the records for those. So right now we can see that there is no 500 in this data anymore. So this is just the caution that I mentioned. There is no undo button in SQL. If you remove something, it's gonna gone forever. So if you want to also, that's why sometimes when people are real world, they are working with some table, they just first create a copy of the table and then work on that table. If everything is okay, they're gonna drop the previous table. Okay. So we have almost 10 minutes. Any questions? For sure you have questions. Ask me. If you don't want to ask, it's okay. But you need to go and practice. You need to go through each of those boxes. Watch the YouTube videos. I'm gonna put it today or tomorrow for you. Read all of them line by line, and you are gonna be absolutely fine. Trust me. If it's a little vague for you, it's totally normal. This is the totally new things to you. And if you are not confused, maybe that's the mistake. You have to be confused at this moment. So let's give you some gift for the assignments. Assignment 2.1. So in this one, we are just working on one single table, simplified sales table. Sale date, first name, last name, product name, category, color, item size, manufacturer name, and price. We haven't worked on this assignment in class, am I right? No, we didn't. Okay. So the first one. What were the category, product name, and color and item size of the product manufactured by Converse and sold in 2014? So one good point for this example, for this assignment, we are just dealing with one single table. So we don't need to think which table we are going to work. That's the only simplified sales table. Okay? So just give me some idea what should I type for the syntax here. Please don't be shy. So we will start with the select. We are going to have the category, product name, color, and item size in the select statement instead of asterisk. So we are going to know the product manufactured by Converse. So manufacturer name should be Converse. And sold in 2014. The sale date should be 2014. Okay, so we talked about the year function of the sale date equal to 2014. So we are selecting category, product name, color, item size from simplified sales table where manufacturer is Converse and the year of the sale date is 2014. We need this thing here because I don't want to see the duplicated value, even though it's not telling in the questions, but you have to. Just check your logic as well. I mean, think about it. Do you need to, for example, see multiple product name? No, it's ridiculous. And also I mentioned to you, you can run it once with these things, run without these things and see how many records there's difference. So here, if I test the query, I'm gonna have 81 record. If I remove the distinct, I'm gonna have over 100 records. So technically duplicated values. So we don't want to have it. So is this one clear? The first assignment? Nothing new. We have already at least 5 or 6 times tried different types of question class. So the number 2, give the first name and the last name of the customers who have made purchases costing $120 or more but less than 130. So technically it's telling me greater than equal of 100 and less than 130. The only points about these questions, we have to type price twice into the syntax. And for sure, we need to have the distinct, because first and last name there should be unique in the output. So simple, select distinct first name, last name from only one table that we have, simplified sales table, price greater than equal, not equal greater than, just pay attention to the order, and the price is less than 130. And test the query, save the answer. And just pay attention, if you press submit assessment here, it's gonna just submit the first 2 that I just answered. You have to go through the all 10 and then put the submit. And after that, you are gonna receive feedback, and then you have, I think, 3 times, 3 attempts in order to fix this code. Good. Assignment 2.3. Here we are dealing with multiple tables. It's not one table anymore. Okay. So in this case, the first question, list the information in the sale table, telling us sale table is one table, plus product name, category. All of this is going to be on the YouTube, so you can just go back and watch the YouTube video. Okay, so just pay attention right now. Plus the product name, category, and the color for the sale of the green sneakers and green sandals. Green sneakers and green sandals. So I need to go through the categories where the categories are sneakers or sandals, and the color is green. And I'm putting the parentheses here. Just make sure first this condition apply, then combine with this one. The output is going to be only showing me the green sneaker and green sandals. From and use first letter aliases. Okay, it's asking us. So select. We know that this one is going to be sale because it says list the information in the sale table. So all of the column sales dot asterisk. But since we are supposed to use the alias, so we would just put S, because here we are going to define sale is S. Product name, category, color. Product name, category, color. From which table? Sale table. Sale is S. We are joining to product table. Product P on product ID from the product table, sale table, where category is sneaker, category is sandals, and color is green. Nothing new, right? Am I right? So what are the categories of shoes from Puma and in what colors? What are the categories of shoes from Pumas and in what colors? Okay, so we are going to have category, color, and then from manufacturer table to product table, because we are dealing with the category of the product and also the producer of the product, which is the manufacturer. So per manufacturer to product table, how we can address product to manufacturer is through the which common key? Manufacturer ID. Manufacturer ID, where manufacturer name is Tuma, order by color. And the third one, just the sale to product table when they need to have only the sleepers. And the fourth one, everything almost the same, except they mentioned that we are going to have just the January in the output. So the month of the sale days are January. Okay. Now, assignment 2.4, there is a quick trick for it. It's not a trick, it's already written. So since we are gonna work on a new table, okay, that's why if you read this part completely, I will also make sure to post the announcement for it. You have to first create a table name that the table name is product. Okay, we'll talk about this later. Technically here we are creating a new table and we are saying, okay, the first one is product ID, product name, manufacturer ID, category, color, price, description. We are just mentioning this one is the primary key. We'll talk about this later. This one is the character with the 30 characters. This one is integer value. This one is a character with 20. This one is character with 15. This one is the decimal point of 8 numbers plus 2 decimals. This one again is character with 100 characters. So when I mention not null, not null, not null, not null, which means we cannot put null value in this. Just you need to type this code here first. Okay, so when you type this code here, you are first going to create the product table, right? Then just delete this one. And now you have to insert these values to your table. Insert into the which table? Product table, where just the values are, for example, 1500, leather, blah, blah. You see, I removed that attributes name here. You can also put the attribute names here as well. But I removed the product ID, product name again. I don't want to repeat it multiple times. That's the first one. The second one, telling us to increase the list price of all sneakers that you previously added to database by 5%. I would say update which table, product table, set the price column to price times 1.05, 1.05, which means adding extra 5%, right? If the price is $100 times by 1.05, the price is going to be $105. So technically, we are increasing 5%. But where category is sneakers, if you don't put the category of sneakers here, you are going to increase all the price. And the last one is just the deleting all products from the product table that manufactured by manufacturer 100. So deleting from product table where manufacturer ID is equal to 100. So let me stop recording. Just stay with me for 1 minute, please.